So let's look at this extension 2 question from North Sydney Boys. Question 16d is the last question, so you would expect it's going to be hard, but this one isn't actually really that hard. So you can pause the video to look at the question. Now, the first one is it gives you a function that looks quite complex, right? And it asks you to find its derivative, which X is a cubic polynomial. So this question, I think all the differentiate questions, they are simple, but it really tests on your algebraic skills and how you can deal with these things without making a silly mistake. So let's look at this. It's a function that got actually three functions multiplied together, right? So we know the rule for differentiating two functions multiplied together. So we just find how to differentiate two of them, and then after you know how to differentiate two of them, you just do it again. So that's just adds another layer of complexity. So what we need to do is we need to choose actually which one is we want to differentiate first, which two. So we can see these three functions, but which two do we want to differentiate first? I chose this one, as you can see, because I think it's the easiest one. A minus x to the time of n, after you differentiate it, it still looks like a friendly way, and it's literally what we learned first in differentiation. It doesn't require these square roots on the numerator and things like that. And e to the power of bx is exponential differentiate, is also quite simple. So after you differentiate using the product rule, you'll be able to reach this conclusion. So now we need to repeat it again by using this as a whole function times with this function. So again, use the product rule, we get this. I think it's a nice trick how you write them in two lines, because you can see the similar terms and you don't actually you write out of the page if you don't do it this way. And you can see that this actually a common factor here. Now the obvious thing you can do is to take them out, and now you just want to know what the Qx actually is. And this is the hard step about the question, which is simplifying this chunk of algebra. But it just needs you to be careful and checking that you've actually done these. So I look at the marking criteria, they actually accept how you just don't simplify it any further, you just do it here. It's okay as well, but I would prefer to do this because it's how you actually simplify it to the end. Now let's look at the second question. Determine this indefinite integral. So it's hence, and it's obvious that this question 1 is used to help you doing question 2. So you definitely need to plug in some values, and you knew the derivative in question 1. So after you do the inverse operation, which is you integrate both sides, you'll be able to get this, right? So if you integrate the derivative, you get the original function. Now it's just the number which you should plug in is n, b, and yeah, just these two values. Now you should actually plug in the values of a, n, and b. So let's look at what values we should plug in. My first instinct is obviously to make n minus 7 equals to 6, which is plug n equals to 7, because it would give you perfectly the 6 that you want. And b, obviously let's 4 in, and then just plug in the value, right, and you get this. But just you need to be super careful to plug in these right, and you just get the original function of y. But when you look at it closely, you found out that, oh, it's not what you should get, because here, instead of a nice 4 to the power of 3 that we've got, it's actually 4 to the power of 4. So it's 1 degree higher. When you think about 1 degree higher, how do you make this degree higher? It's always a cubic regardless of the coefficient you plug in. However, this coefficient can change, and if you make the x minus 2 term out and multiply it here, then you can increase this degree to the power of 4. So if you want to take out one of the x minus 2 term from here, obviously you need to make the index larger by 1. So let's just try, put a equals to 2, n equals to 8, and b equals to 4 here. And again, you need to simplify this very correctly. Now just do what we just said. We need to make this, the highest term is x to the power of 4, so you multiply 1 x minus 2 out to get this, and afterwards you get this relationship as well. So now you have 1 and 2. You just want to get what's in the question, so you need to do some algebraic manipulations by adding them together. So if you observe very closely, you can see that if we multiply the first one by 2 and plus them together, you'll be able to make these to actually add up to the one in the question. So this questions is actually not that much logic, but it's trial and error, and it really tests how you can make this one right and how if you can sub in right. And I think it's a question of trial and error, but it's not that hard to guess what you need, because this is first instinct, and after you get this you realize, oh, I need a x to the time of 4. So that's when you plug in n equals to 8, right? And after you get these two expressions, it should be easy to see how you obtain the final result. So after you add them up together, you get this. And that's this question. Again, I think instead of a really logical question of constructing, it's really more of testing if you have a strong calculation ability. And it's not chucking the calculator. You can't chuck in the calculator for this type of question. It's just pure algebra. And again, it tests on your ability to try. It's not a logic question. You know exactly how you should construct this, but instead by actually trying and to find a way. Sometimes if you don't know how to do it, you can use some conclusion from the first question and try if you can reach the conclusion. So I think I'm a student, obviously, but these videos aren't really of great quality, but teaching is a part of learning, and I'll continue to make these videos because I think it will make my math better as well, and it can help others, so why not? So subscribe if you want more videos like this, and you can, so like the video if you want to support me as well, and leave any feedback in the comments area for any improvements or alternative methods.